All right, so our procedure or our strategy for solving the optimization problems. First, we're going to introduce variables. We're going to look for relationships among the variables and construct a mathematical model of the form maximize or minimize some function f of x or c of x or a of x or whatever it is on the interval of I. Then we're going to find the critical numbers of f of x. And then we're going to use the procedures developed in section 11.5, which we finished last time, to find the absolute maximum or minimum of f of x on the interval I and the numbers x where this occurs. And then we're going to use a solution to the mathematical model to answer all the questions that are asked in the problem itself. All right, so here, what we're going to do is minimize the perimeter. And a homeowner judges that an area of 800 square feet for a garden is too small and decides to increase the area to 1,800 square feet. What is the minimum cost of building a fence that will enclose a garden with an area of 1,800 square feet? What are the dimensions of this garden? Three sides of the fence will be constructed with wire fencing at a cost of $2 per linear foot, and the fourth side will be with wood fencing costing $6 per linear foot. All right, so it's going to be similar to our last one, and let's go ahead and go back to the purple again. So we're going to have our rectangle. We're going to have a $2, we're going to have a $2, we're going to have a $2, and this time instead of 8, we're doing a $6. Okay. And what do we want to do? We want to find and we want to minimize the cost, or C of X. Hopefully is X is what we're going to use. Maybe we'll use Y, I don't know, but it's going to be C of something anyway. All right, so how is that going to be? Well, in this case, what we're going to do is we're going to do kind of like we did last time. Our C of something, let's call it C for now, maybe. Let's not actually say, we're just going to minimize cost. We're not going to say what it is because we might end up using one or the other. And so we'll minimize C, which is our cost. And so C is equal to what? Well, it's going to be, if these are, let's call this one X again and this one Y again. We're going to have what? 4Y plus, and that's 2 plus 8, that's be 8X. Okay. And what do we know? We know that X times Y is equal to 1,800 because it's going to be 1,800 square feet instead of 800 square feet. And again, we know X and Y both have to be greater than equal to 0. Okay. And so that's going to be kind of what we're doing. And so let's go ahead and say, let's minimize this cost. And these are kind of what our things that we're subject to. So we're going to say subject to X times Y has to be 1,800 due to the fact that that's what they give us here in the problem. And we know that the lengths and widths can't be 0. Okay. All right, so let's do like we did last time. Let's solve one of these, and let's do this second one here. Let's solve this one for x, because that's kind of what we did last time. We solved for x, and then we did c of y, so we'll do it again that way. So 1,800 divided by y. So c of y then is what? Well, plug that in. We have 4y plus 8 times 1,800 over y. And again, y cannot be equal to 0. It has to be greater than 0 in this case, because if you have equal to 0, you divide by 0, we're out. We can't have that, okay? So that one's not going to work. And so now we have this. Now c of y is equal to what? That's going to be 4y plus, and that's going to be 64. That's 12, 13, 4. So that's going to be 14,400 over y. And we'll just say that still stays the same. All right, so now what we need to do is we need to find that first derivative. Well, the derivative of the first piece here is going to be a 4. Now, when we take that y up and make it y to the -1, then we'll have a -1 times, so we have a -1 times 14,400, and then we'll have a y to the -2, which now becomes y squared in our denominator, okay? So now what we can do is we can set that equal to 0, and we can solve for y. So if we do that, we have, maybe we can do it over here. I don't know where the best place. I don't know where we're going to run out of room. 14,400 over y squared equals 0. So let's take our 14,400. So we have 14,400 over y squared equals 4. So if we multiply both sides by y squared, that will get rid of it here. So now we can kind of maybe change our color. And so we have that cancels that. But now let's also get rid of that 4. So let's multiply by 1/4, multiply by 1/4, because then that 4 cancels that 4, and we're left with just y squared here. And then that 4 will go in here, 4 will go in here, 3, and then we'll have 24. So that's going to be what, 600. Okay. So that will be our new equation, which is going to be y squared is equal to 3,600. All right, so square root each side, that's going to be y equals 60. Okay, now we can't have a positive and negative. We can only have the positives. And so this is going to be our critical number. Okay. Um, so now if that's y is 60, can we get x? Yeah, we can plug that back over here. And so x is equal to 1,800 divided by 60. Well, one of those goes off, so that's going to go in there and we're going to get 30. Okay, so that works. All right, so now what we're going to do is we're going to do our second derivative. So that kind of got us the first part. So we got x's and y's, critical numbers and pieces. So now if we take our second derivative, let's move that over a little bit here. Well, that 4 is going to disappear. We're not going to have that. This is going to be a y to the negative 3. So we're going to have a negative 3 times this. And so that's going, or negative 2 times this rather, and then it becomes a negative 3. So negative 2 times that's going to be positive 28,800, and then it becomes y to the third. Okay. Now that's our second derivative. Now, if we remember from the last section, we plug in our critical number into here and see what we get. So we have a c double prime of 60 equals 28,800 divided by 60, and that's to the third. And if I get my calculator out here on the side, that's going to give me, looks like 0.133. Okay. Now, what do we know about that value? Well, that's going to be what? That's greater than 0. And so it's going to be a local min. Okay. And since it's the only critical number, that also means it has to be the absolute min. So only critical number, therefore absolute min as well. And so now we can kind of work backwards and we can find out what our values are. So if we go and say, what is C of 60? That's going to be what? Well, that's going to be 4 times 60 plus, and then we have what? 8 times 1,800 divided by 60. And if we work on our calculator one more time with that one, it looks like we get 480. Okay, so that's going to be that. And so that will be the cost. And so then our dimensions sounds like, do we want dimensions? Yeah, we want dimensions. Are going to be what? Well, it's going to be 30 feet by 60 feet. Okay. And one of the 30 feet is going to be the $6 wood. And then the other 3 other sides are going to be the $2 wire. And the total cost is going to be what? Well, that's going to be that $480. Okay. All right, so I think that should be everything that they asked for, and so hopefully that will help you with that one. And we'll come back for in a little bit with another one.